Hello and welcome to the second video which accompanies the Microeconomics for Business course, and this workshop will be on algebra. We're going to look at what algebraic notations are, then we look into a little bit more details what Botmass is, which is telling you the orders of operation. Then I show you quite a few examples on working with formulae. Then we look at how to solve linear equations, and in the last section of the video we are going to talk about what's the difference between the direct and the inverse demand functions and how you can get from one to the other. So let's get started and look at algebraic notation. So on the screen here you can see some notes. So I've written PQ versus TR. Now in every subject area, and so in microeconomics and mathematics, certain letters might have got some specific meanings. In this case, in microeconomics or in economics in general, capital P usually stands for price. Q, capital Q, usually stands for quantity. And when I look at PQ, I'm talking about P times Q. Because in mathematics, if there is no operation sign between letters, we always refer to multiplication. However, in the case of TR, this is not a multiplication, this is a shortening of total revenue. So be aware that sometimes double letters refer to multiplying the two concepts together, or rather the numbers that accompany those concepts, but sometimes they mean something totally different. Now, in the second line, we have got something like AP and a little l down in here, and also AP with a little k down in here. Now again, these are specific for this module and microeconomics, and what they mean is average product of labor or average product of capital. So again, certain letter combinations carry a lot more specific meanings than just similar letters. And in the last example, we see TC being equal FC plus VC. Now again, this carries a very specific meaning. TC stands for total cost, FC stands for fixed cost, and VC stands for variable cost. So again, don't forget that in this particular case, what this formula actually tells me is to calculate the total cost as the sum of fixed cost and variable cost. In this particular example, there are no multiplication involved. But if we wanted to calculate, let's say, the total revenue can always be calculated as price times quantity. And in many cases, to make sure that people don't confuse the two things, we might just in case write out the multiplication sign in between the two letters. Let's move on and talk a little bit about Botmass. As you can see on the screen, Botmass is an acronym. B stands for brackets, O stands for other operations, and by other operations I mean the indices, the roots, and any other more complicated operations. D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. So whenever you see a long and complicated algebraic expression, if it has got brackets in there, that's what you need to attempt first. If it has got any other kind of operations like squares, higher powers or roots, then they come next in the line. Then the peculiarity is that, or the division comes in front of multiplication, they are at equal level. So you can swap the orders of divisions and multiplications around. You don't always have to do division first and then multiplication next. These two can be interchanged, and so is addition and subtraction. However, if there is a multiplication or a division, you have to do that before addition or subtraction. But again, adding or subtracting, you can switch the orders around and make your life a little bit easier if you have to do calculations by hand. So let's look at some examples. So here is this long calculation. If I look at this calculation and apply Botmass to it, I see that I have got brackets in here. So I need to deal with the brackets first. And where there is no calculation sign between a bracket and a number, in mathematics we always refer to multiplication. So that is always multiplication. So what I need to do now, I need to carry out 7 minus 15, which gives me negative 8. And I need to multiply that by the 3. Plus, I have got another bracket in here. 8 minus 12 gives me negative 4. And I need to square that. Now, although I still have got the brackets in here, there are no more calculations inside those brackets, so I can move on to the next acronym, the next letter in the acronym, which is O. So I'm looking for any other operations, and there it is. I have got a square in here. So what I need to do first, I need to square minus 4. The square of negative 4 is just negative 4 times negative 4, which gives me positive 16. And what I have got here now is a multiplication hiding here plus an addition. Now the multiplication is a higher operation, so what I need to do, I need to do the multiplication first. So 3 times 8 is 24, so that gives me minus 24 plus 16. And if I look at the two of them, the negative is a bigger value. So I have got more debt than I have got money. So I'm going to end up with a debt in my account, and I'm going to end up in a debt of £8 because the difference between the 24 and 16 is 8. So again, if you're not familiar with positive and negative numbers, how to deal with them, do refresh them looking at the previous video. Now let's look at the second example. Bracket square root of 25 minus 8 bracket goes to the power of 3 plus 15. So again, following Botmass, I do have a bracket. So what's going on inside the bracket? Inside the bracket, I have got a root and I have got a negative sign, which is subtraction. Out of the two, the root is a higher operation, so that's what I need to do first. So root 25 gives me 5. And now I carried out taking the root of the 25, I can move on to the next calculation within the bracket and I can carry out the subtraction. So 5 minus 8 gives me negative 3. And although I kept the bracket because I need to take the negative 3 to the third power, not just the 3, therefore I still need to keep the bracket, but there is no more operation inside the brackets. So the calculations I left with is taking the cube and adding. Out of the two operations, the taking the cube is a higher operation, so that's the one that I need to carry out next. So negative 3 to the third power, or cube, means that I need to multiply the negative 3 by itself 3 times. So I'm going to end up with a negative number, and 3 times 3 times 3 is 27. So I've got negative 27 plus 15. Again, if I look at the two numbers, the 27 is the bigger in magnitude, and that has got a negative sign in front of it, so my answer will end up being negative. And the difference between 27 and 15 is 12. So I end up answer being negative 12. Now I showed you how to do these calculations by hand, but in most cases you will be allowed to use the scientific calculator. So a quick refresher on how to do it with the scientific calculator comes now. Your scientific calculator is very useful because it has Botmass built into it. Now if I was to do this with an ordinary calculator, I would need to tell the calculator which operations to do first. So first of all, I would need to do the 8 minus 12, then square that, write down the answer to it. Then I need to do the 7 minus 15, multiply the answer to that by the 3, write down again, and add the two things together at the end. So quite a lot of staged steps involved. However, with the scientific calculator, I can just write this all in one go. So 3 bracket 7 minus 15 bracket closed plus next bracket open 8 minus 12 bracket closed square. Hit equal and we got the answer minus 8. Quite a bit faster. The second example was very similarly. Bracket open, square root 25. Make sure that you press the arrow button so you come out from the square root, otherwise everything will be taken under the square root. Minus 8, bracket closed, and now you can raise it to the cube, so there is a separate button for the cube. Plus 15 equal minus 12. So if you know how to use your scientific calculator accurately, that will save you a lot of time, especially in a nervous exam situation. Let's look at some examples that are a little bit more familiar and come from the subject of economics. So let's say that you were given a function 2q squared minus 4q plus 150 and need to find the value of this function when you know that q is equal to 10. Now, first of all, what we need to do is we need to substitute the letter q for the number 10. 2 and q has got no calculation sign in between, so that refers to multiplication. So I've got 2 times 10 squared minus, same case in the 4q, I need to multiply the 10 by the 4 plus the 150. So if I was to do it without a calculator, again I need to refer back to Botmass. I've noticed that there are no brackets, so the next highest operation I need to carry out is the power, because that belongs to the other group. So what is 10 squared? That is 100. The next calculation I can do is multiplication, because that's the next in the list. So that's 200 minus 40 plus 150. And what happens now? I have got subtraction and addition. As I said before, they are interchangeable. So I can do the additions first and the subtraction next, or I can do the subtraction first and the addition next, whichever you find easier. I usually find doing additions easier, so what I'm going to do, 200 plus 150 is easier to add, so that would be 350 minus the 40, altogether gives me 310. Again, just a quick refresher how we can do it using the calculator. So 2 times 10 squared minus 4 times 10 plus 150 again gives us the answer of 310 quite quickly. Now, the next topic I would like to talk about is how can we work with formulae. On the screen here you can see quite a long formula. So qx equals 15 minus px plus 0.001 m plus 0.5 py. Now this is something that you probably have already come across in your lectures, but just to recap, what are these different letters stand for? Well, Q is always quantity and X is one product, so it's the quantity of product X. P is always price, and because X is here again, we're talking about the price of product X. Capital M usually refers to income, and PY refers to the price of product Y. So there are two different product prices are involved in this formula. So here's a practical question. Let the income be 3,000 and the price of product Y be 20. What is the direct and inverse demand function for product X? So for this question to be answered, we need to identify what 3,020 stands for in the formula. Okay, when you read the instructions, it says let the income be 3,000 and the price of product Y be 20. That tells me that M is equal to 3,000, while PY, the price of product Y, is 20. So what is the direct and inverse demand functions for product X? First, what we need to do is replace M with 3,000 and PY with 20. And then do a little bit of calculation. So 15 minus PX plus 0.001 times 3,000. Remember, if there is nothing in between a letter and a number, that's always multiplication in mathematics, plus 0.5 times again 20. So we have got a few calculations here that we can carry out. So pick out the scientific calculator again. So you've got 0.001 times the 3,000. That's going to give you positive 3. So this is 3. And 0.5 times 20 going to give us 10. But we could have calculated it because we know that 0.5 is half and half of 20 is 10. But how many numbers do we have all together now? 15 plus 3 plus 10. So that's altogether 28. So QX equals 28 minus PX. Now, this is our direct demand function. Because knowing the price, we can calculate directly what is the demand for X. So how are we going to calculate the inverse demand function? The inverse demand function will be Px expressed as a function of Q. So I just need to rearrange this equation so Px would be on its own on one side. So I need to move Px to the other side. So that's Px plus Qx equals 28. And I need to remove Qx from here, move it to the other side. So Px equals 28 minus Qx. And this is going to be our inverse demand function. So the direct demand function is the demand function which is expressed as Q equals something, and that something is a function of P. And the reason why we call it the direct demand function is because if I know the price, I will be able to calculate the demand directly. Now the inverse demand function is when I have got the price as the function of Q, or the price as the function of the demand. Basically, we call it the inverse demand function because to be able to calculate the demand, we have to do some inverse calculations. Now, let's look at this kind of question again with slightly different numbers. So QA equals 50 minus 5PA plus 0.01 M plus 0.4 PB. Again, the question is, what is the direct and inverse demand functions? So in this next example, when you read the text, you can see that the income is 5,000, so I can record that M is equal to 5,000. The price of product B, so PB, is 25, and again we need to find the direct and inverse demand functions. So first of all, let's substitute back the numbers into the formula. Now M is equal to 5,000, so I need to multiply the 0.01 by 5,000. Plus PB is equal to 25, so I need to multiply the 0.4 by the 25. So let's bring those numbers together. 0.01 times 5,000 gives me 50. and 0.4 times 25 gives me 10. So again, what I can do, I can bring those numbers together. 50 plus 50 makes 100, plus 10 makes 110. So I found the direct demand function. Now what I need to do is find the inverse demand function. So I need to rearrange this to have PA on its own on one side. Just like in the previous example, PA is negative in here, so I need to remove it and put it onto the other side so it would become positive. But this example will be slightly different because in the previous one we only had one P, but now we have got 5 of them. So what I've got here is 5PA plus QA equals 110. So I'm getting closer, but I need to remove the QA because I have to have PA on its own. So removing the QA means I need to take it away. So then 5PA will be 110 minus QA. And I'm almost there, but in this case, I have got 5PA on the left-hand side when I just want one of them. So what I need to do, I need to divide them by 5. So if I need to divide them by 5 here, I need to divide them by 5 here as well. So those 5's cancel each other out. So I've got PA being equal to. Now, this is a division when I have got a subtraction at the top. Now what I can do, I can carry out the division term by term. So I can do 110 over 5 minus QA over 5. So PA then would be 110 divided by 5 gives me a nice 22. And QA over 5, dividing something by 5 is the same as taking the fifth of it, so I can rewrite it as 1 over 5 QA. And the reason for why we want to write these things in this particular format and not leaving it QA over 5, so we would see a little bit better about how fast the Q changes influence the changes in price. Now let's move on to slightly different examples for working with formulae. So here are 3 formulae, and first of all, what do these different letters in the different formulae mean? Well, Q we already seen. Q is always the quantity, but L appears first. From your lectures, you can recall that capital L always stands for labor. APL is the average product of labor, and MPL is the marginal product of labor. So APL we already mentioned, but MPL again is the marginal product of labor. So it's important that you know the difference between these 2 letter combinations because they have different concept. Therefore, the calculations that you have to carry out to find these particular formulae will be different for different demand functions. So there is one more question that I put here is what would they mean if we replaced L with K? Now, you might recall that capital K means capital. So if I was to replace L with K, then I would be talking about the average product of capital and the marginal product of capital in these particular cases, and then the product and then the quantity would be given as a function of capital instead of the function of labor. So let's see now what kind of calculations we can do with these ones. So the question is, what would be the value of Q, APL and MPL if I know that L is equal to 25? Now, to be able to calculate these without a calculator, I need to know the rules of indices. which sometimes also refers to as rows of powers or exponents. Just to confuse pure students, in mathematics some concept can have exactly 3 different names. Now, for these rows of powers, in these particular cases, what we need to remember is what are negative powers and what are fractional powers. So if I have got any number raised to a negative power, that is by definition exactly the same as 1 over the positive power of the same base. And if I have got a fractional power, that means that the bottom of the fraction represents the root and the top of the fraction represents a power. So n over m then become mth root of a to the n. So what does that mean for us for this particular case? So if I've got q equals 4, don't forget, if there is no calculations, I always need the multiplication sign, and L is now 25 to the half. What does that mean? So the 4 times says, but 25 is, 25 to the half is basically 2 is the root, so it's the square root, for which we don't write the 2 out because this is the smallest root, and then 25 I need to raise to the power of 1. And again, the 1 we usually don't write here because 25 on its own means exactly the same as 25 to the power of 1. But square root of 25, we know that it's equal to 5, so the quantity is 20 when the labor is 25 and this particular function is given. So what happens in the case of the APL, the average product of labor? So that is slightly different because 25 is now to the minus half power. So what we can do now, remember that what a negative power means. So negative power means that we need to bring the power down into the denominator. So we got 4 times 1 over 25 to the half, and in this particular case the 25 to the half is exactly the same as above, so this will be 4 times 1 over root of 25, and the root of 25, as we established before, is 5, so 4 times a fifth is just simply 4/5, because 4 times 1 gives you 4, and you don't multiply the denominator by the number. Marginal product of labor is the last formula on the page, and that's again slightly different because instead of the 4 I have got the 2 in here, so it's 2 times 25 to the minus half, but these parts are exactly the same as it was above. So 2 times 1 over 25 to the half, which will be 2 times 1 over root 25, which will be 2 times a fifth, and that is 2 over 5. Now that is all nice and lovely if you are familiar with the rules of powers, but if you are not, help is at hand because you have got the scientific calculator. So for using these calculations, for carrying out these calculations with the scientific calculator, all you need to remember is how to substitute the given values into the formula correctly and then let the calculator do the hard work. So what I need to do is 4 times 25. Now that half needs to go into the power. So first I'm going to have to press the power button, not the square, not the cube, but the power button. And in that power I want a fraction. So I need to press the fraction button and I need to type in 1/2. And notice that I'm navigating with the arrow buttons. Now I typed in everything, so I can hit equal, and voila, it gives me the number 20, nice and easy. The next one, 4 times 25. Again, I'm going up into the power, but now I have got a negative number, so I need to press the negative sign, and then I need to put in the fraction. And again, I'm typing in 1/2 equal 4/5 straight away. And the last question, everything exactly the same except for the 4 nice 2. And that is equal to 2/5. Now, in economics, in most cases, you are talking about decimal numbers. So the 2/5 isn't necessarily the correct answer. Isn't necessarily the final answer. So you probably want to use the SD button and then turn it into a decimal. And same with the 4/5, which again, turning it into a decimal, 0.8. Let's look at some more formula examples. Now I have got a different demand function, Q equals 5K plus 10L. So this particular demand function depends on both capital and labor. And the question here is, how much unit of labor is applied when the total output is 10,000 and capital is 5,000 units? So let's just establish what we know and what is the question. So how much unit of labor is applied? So what we're looking for is capital L. When the total output, well, Q is the demand or sometimes also output, is 10,000 and capital is 500. Now let's put everything in that we know into the formula and let's see what that leaves us. So I know that the Q is 10,000, so in this side I have got 10,000 and I've got on the other side 5K, which is 5 times 500, given that K is equal to 500, plus 10 times L. Because I don't know the L value, I need to calculate the L value. So what I need to do, carry out the 5 times 500 first, which is 2,500, and that is plus 10L on this side. Now I want to know the value of 1L. So that gives us 2,500 and 10L on the right hand side. But we want to identify how much is one of those L's. So what I need to start to do, I need to start to rearrange this whole thing and solve it for L. So there is plus 2,500 in here. To remove that, I need to take it away. So what I need to do is 10,000 minus 2,500 will give me the 10L. 10,000 minus 2,500 gives me 7,500. That is equal to 10L. To get to 1L, I need to divide by 10. But if I divide by 10 on this side, I need to divide by 10 on the other side as well. So these two cancel out, and dividing by 10 is very easy in this particular case because I can just cancel down by one of the zeros. So I found that I need 750 units of labor for this statement to be true. Let's look at a somewhat different formula, but is still output involved with capitals and labors. Before we look at what the question is, let's have a look at a little bit closer of this formula. K is raised to the 0.5, L is also raised to the 0.5, but there is no calculations whatsoever between the two of them, so that tells me that I need to do a multiplication in here. So let's see what the question is. The question is how much capital is applied when the total output is 30 and the value of labor applied is 25 units. So the question is, what is K when we know that Q is equal to 30 and L is equal to 25? So let's plug these numbers back into the formula and let's see what we're left with. So Q is 30, that is equal to K to the 0.5, because I don't know K, that's what I need to calculate, which needs to be multiplied by 25 to the 0.5. Now I remember that 0.5 is the half, and I remember that the half power is the root, because we looked at in the previous example. So this can be rewritten as k under the root times root 25. And that's quite handy, because root 25 is just 5. Now, what I want to do in here is I want to identify k. I'm not interested in root k times 5. My final goal is to get to k. So I need to divide them by 5 both sides. So I end up with 6 being equal to root k. But now that root is in my way. So how can I remove that root? Well, remember, with all these formulas and equations, what we do here when we're solving it is always opposite calculations. When there is a multiplication between the variable that I'm trying to find and some numbers, I do the opposite of multiplication, which is division. If there is an addition, I do the opposite of that addition, which is subtraction. So the question is, what is the opposite calculation, the calculation that undoes the root? Well, that is raising to the second power. Just remember, square root of 2 squared gives you 2. And also, square root of 2 squared still gives you 2. So the root and the square are each other's opposite calculations, the same way as multiplication and divisions are. So I want to remove the square root, so I'm going to have to square the whole equation. So that will give me k, but then I need to square the 6. 6 squares is 36, so the capital that we need to apply for this to be true with 30q and 25l is 36k. Now the next question when it comes to formulae is q is given by 4k plus 6l, and the question is, what is the average product of labor when 5 units of labor and 10 units of capital is applied? So the question is, what is the average product of labor when we know that labor is 5 units and capital is 10 units? Now, to be able to solve this question, we need to remember the formula for the average product of labor. And the average product of labor is nothing else but the output divided by the labor. If it was average product of capital, it would be the output divided by the capital. So what we need to do now, we need to substitute back into this formula the particular output function that we got here, which is 4k plus 6l divided by l, and then we need to substitute the given values for k and l. So 4k is 4 times k, so that's 4 times 10, plus 6l is 6 times l, which is 6 times 5, and divided by 5. Again, what I need to do first, I need to do the top, which is 4 times 10 is 40, plus 6 times 5 is 30. 40 plus 30 gives me 70. And 70 divided by 5 is equal to 14. Now, if I wanted to be very, very lazy, then I can just come to this point and put it all into the calculator in one go and let the calculator to do the calculation. For that, I would need to put the fraction in first, then 4 times 10 plus 6 times 5, then come down and give 5 to the denominator, and that is equal to 14. So if you're not very familiar with all these nitty-gritty calculations, don't worry, you are allowed to use the scientific calculator. One more question about formulae, and then we can move on to working with equations, how to solve linear equations. So the last formula is the one that we've already seen, but the question here is now, what is the average product of labor and the average product of capital when 9 units of capital and 25 units of labor are applied? So what is the average product of labor and what is the average product of capital? So there is 2 questions now. when capital is 9 units and labor is 25 units. So again, the average product of labor was the output divided by the labor. So the output is K to the 0.5 times L to the 0.5 divided by L. And now I know that K is 9, so it's 9 to the 0.5 times 25 to the 0.5 divided by 25. Now again, remember that the 0.5 power is the same as the half power, and the half power was the root, the square root. So that basically tells me that this is square root of 9 times square root of 25 divided by 25. So square root of 9 is nice and easy 3. Square root of 25 is the nice and easy 5. And then what I can do in here is I can see that I can cancel down the 5 and the 25. So that cancels down to 1 and this cancels down to 5. So what I end up with is 3 over 5, and that is 0.6. The next question is the average product of capital. Now that is very similar, but that can be calculated by dividing the output by K. So the first part is the same, but the bottom now becomes K. So with the number values, so the top is exactly the same, root 9 times root 25 divided by 9. So that gives me 3 times 5, but now I'm dividing it by 9. So now I can cancel down this. And that gives me 5 over 3. And unfortunately, 5 over 3 is not a nice and easy decimal, because if I calculate that to decimal equivalent, it's going to be an infinitely recurring fraction. So if I wanted to round it to the nearest 2 decimal places, that would be 1.67. Again, if I wanted to be lazy, I could do the calculation from this point using the calculator. I'm going to show you the first example, and the second example you can try on your own. So I notice that there is a fraction, so I'm going to put the fraction in, and then I'm going to say 9 to the 0.5, and notice that the calculator can do decimal powers as well. So I can come down next, multiply 25 to again 0.5, then come down to the bottom and just put the 25 in, and voila, it gives me the 3 over 5, which is 0.6. In the next section, I would like us to concentrate on solving linear equations. So you are given this equation, q equals minus 45 plus 8p, and the question is find q when p is 250. So what it tells you is that the p value is 250, but I need to solve the equation to find the value of q. So q is equals minus 45 plus 8 times 250. And that's quite easy because I don't need to do any manipulations to get to q, so I can just put all that into the calculator and it will calculate the value of q for me straight away. So negative 45 plus 8 times 250, that gives me the q value of 1955. So if you are given the direct demand function and the price and are asked to calculate the quantity, that's a very simple and straightforward calculation. But what happens if I'm given the demand function in a slightly different way, such as in here? So 13p minus q equals 27, and I'm given the value of q being equal to 12, and I need to calculate the value of p. First of all, what I'm going to do, I'm going to substitute q for 12. So I've got 13p minus 12 equals 27. And because I want to get to P, I need to remove the minus 12. The way to remove minus 12 is to add 12 to both sides. So that will be 13p minus 12 plus 12 gives me 0. So that's the reason why I'm doing the add 12. And on the other side, it will be 27 plus 12. So 13p equals to 39. But now I just want one of the p's, not 13 of them. So I need to divide them by the 13, both sides. That cancels down to 1, so I'm just gonna left with the p. And 39 divided by 13 is conveniently equal to 3. Next example, q plus 4p minus 240 equals 0. The question is, what is p equal to if q is 40? Again, substitute the value back for q. So 40 plus 4p minus 240 equals 0. Positive 40, negative 240 makes it negative 200. So I have got 4p on this side with a negative 200. To get to the p, I need to first deal with the negative 200. So what I need to do, I need to add 200 to both sides, because positive 200 is the one that cancels out the negative 200. So in this side, therefore, the negative 200 will disappear. And on the other side, 0 plus 200 will give me 200 together. And last step, I've got 4p, but I want to have 1p, so I need to divide both sides by 4. So 4 cancels down. P equals 200 divided by 4 gives me 50. And the last question for today is manipulating equations without numbers in them. So the question is, find the inverse demand function for the following direct demand functions. So in A, I have Q equals 100 minus 5p. So this is the direct demand function. The inverse demand function would be P equals number and Q on the other side. So what I need to do now, I need to manipulate this equation in a way that I will have P on its own on one side. P here is negative. To make it positive, I'm going to move it to the other side. So 5p plus Q equals 100. Now I want P on its own, so I need to remove the Q. So 5p will be equal to 100 minus Q. So I'm removing a positive Q by taking it away from both sides. But I've got 5p and I want only 1p, so I need to divide them by 5. And remember, on the other side, I can divide each of them by the 5. So that cancels down. So P is equals 100 over 5 gives me 20, and the minus Q over 5, and I can always rewrite as 1/5 of a Q. So that's given me the inverse demand function. Second example, Q equals 50 minus 2p. Very similar to this one, but different numbers. So the solution process will be the same, but the numbers will be different. Move the P to the other side. Move the Q to the other side. And then divide them by the 2. So P will be equal to 50 divided by 2 gives you 25 minus half a Q. Remember, dividing by 2 is the same as multiplying by a half. And the last, C, Q equals 80 minus 4p. So same process, move the 4p to the other side. 4p plus Q will be 80. Remove the positive Q, so 4p will be equal to 80 negative Q. And then divide them by the 4. So that cancels out. P equals 80 divided by 4 gives me 20 again, but q over 4 now makes it a quarter of the q. So this is what I would have liked to introduce you to in this video. I hope it will help you with your studies in microeconomics for business, and feel free to get in touch if you have got any particular questions about any of these mathematical calculations.